Hi guys, Mr. Kane here. Just going to go over a couple of the quick procedures that you'll need in the Target Gas Law Lab. A few of the things that you're going to need at your table that should be set up already is you're going to need your ring stand along with this large clamp. You will have a magnet along with a paper clip. The water trough contains one hose on one side that's hooked up to an Erlenmeyer flask. You'll have a thermometer, and there will also be a nice little target for you to be using to shoot for your grade. You'll have already measured the mass of your piece of zinc. So you already have done some calculations with this, and you'll have your pre-lab with you, which is already filled out. So in order to get this initially set up, my suggestion is this. Set up your graduated cylinder so it's flat, which is on the drain side. Get a beaker and go ahead and fill it with tap water. You want to fill it as full as you can get it without having it go over. Once you've done that, the technique is very similar to the one that we did first semester when we were catching a gas in a smaller graduated cylinder. You want to basically just kind of swipe your plastic wrap over the top, trying to keep any air bubbles that form as small as possible. I'm okay with that air bubble. This is just a test after all. Okay, you want to pick up the graduated cylinder out of the sink fully.
And the students want no air bubble, correct, Mr. Kane?
You want no air bubble, or as small of an air bubble as you can manage.
All right.
All right. Now the way I'm going to do this is I'm going to put my left hand on the bottom because I'm a right-handed person. I've got both my hands inverted so that when I flip this over it'll be real easy to hold. I'm going to put it straight in, and as soon as I get it under the water, so as soon as you get it in there, you can go ahead and you can peel the plastic wrap down. It's not going to let any air bubbles out as long as you do this slowly. All right, you want to peel the plastic down all the way and then just kind of peel it off. Okay. Don't damage the plastic wrap because we're going to use it again next hour. All right. Now that does stand by itself pretty well, but you want to get that being held in the big jaws pretty quickly, because if it does fall, these things are expensive. Okay, so I'm going to get that in the jaws, and then I'm going to move this over to the gas collection hole, which I don't know if Mrs. G saw that on the video or not. There's the gas collection hole right there. So if we want to collect gas, we have to move that over the hole. All right. Now, my pre-lab data isn't the current temperature and isn't the current pressure. So when you walked into class, you'll have recalculated everything for real, and you now know exactly how much this piece of zinc is going to produce, how much hydrogen gas this piece of zinc is going to produce. I'm going to set this up, and I've already figured this out. So here's the procedure. You're going to call me over, and I'm going to add the 9 molar hydrochloric acid to your Erlenmeyer flask. Nine molar is pretty concentrated.
Goggles are on, correct, Mr. Kane?
Goggles are definitely on at this point in time, from this point on. I'm going to fix that on, and I'm going to kind of curl it around like the lab says so that it's going to fit inside of the Erlenmeyer's neck. You can do a variety of things with this. You could actually fold it up like this so that it stays there, or you could just curl it around the way it says. It won't matter, because what you're going to do is you're just going to take your strong magnet, you're going to place your zinc right next to it, and it's going to hold on to it. You're going to slowly move that down just a little bit so that the stopper can be placed in place without knocking into the piece of zinc. Just like so. Once you're at this point, there's only one last thing to do. You're going to take your target. My target should be set for 604.54 milliliters. which I'm going to say is just above 600. I said 604, which is going to be just between 600 and 610. So I believe that I'm placing it right there. And before you do anything else, you want to call your teacher over.
Literally reading it from the bottom, which is technically now the top, down. Is that correct, Mr. Kane?
That's correct. 100's at the top, 200, 300, 400,
right.
500. There's 600. 610 is the next line past 600.
Okay.
All right. At this point in time, this is the fun part where we get to make the hydrogen gas. So I'm just going to take the magnets and I'm going to remove it. Everything else is set up. The gas is going to go through the tube and into the graduated cylinder. There we go. We're off to the races.
Almost immediately, you see the reaction occurring. Yeah, Mr. Kane?
Yep, that 9 molar hydrochloric acid has a lot of hydronium ions.
Yeah.
Going to be attacking the zinc.
Creating hydrogen gas and zinc chloride. Mm-hmm. A single replacement reaction.
Now there is a little bit of water vapor being built up inside of there. That's why we multiplied by 1.09 before.
That's because it's a column of water in the graduated cylinder.
And notice that the excess water is actually draining straight into the sink here.
And that's all hydrogen gas and a little water, a lot of water vapor probably.
A bit of water vapor, yeah.
Yeah, because it's probably warm because of the HCl, the
Yeah, I
9
can't-
molar HCl. And how come the paper clip doesn't react, Mr. Kane?
Coated in plastic.
Okay.
So once you've successfully gotten your gas measured by your teacher, you've only got one task left. You've got to dispense with spare hydrogen. In order to do that, you should first make sure that you actually know how to use the aim and flame. If you can't get a flame going with your hand easily, somebody else needs to do it. Here's the basic idea. Hydrogen gas is extremely light and extremely flammable. I'm going to take this out of the, I'm going to take this out of here, being careful not to spill my hydrochloric acid, and I'm going to prepare to flip this upside down and light the hydrogen gas. I'm going to give the hydrogen gas just about a second to get out of my graduated cylinder. Ready?
Ready.
Set. I'm just going to set it right here.
Okay.
There's the barking dog.
Cool noise. I love it.
That's about it, guys. See you in class.